start our lesson. So that is unit 7, it's the magnet lesson, right? So you all know children, we use magnets for our day-to-day activities, right? Okay. So now this is a practical, right? So you all can see there's a glass of water, right? So inside that there's a pin which has fallen inside, right? So now you all have to take the pin out of the glass without spilling even a droplet of water, right? For that, you all can use a magnet. So when you move the magnet upwards on the surface of the glass, the pin is getting attracted to the magnet, so the pin is coming out of the glass, okay? So, in our day-to-day life, there are different instances where we use magnets, right? So, you all know you all have pencil boxes, right? So, in the pencil box, there's a magnet attached to that, right? So, in some chessboards, you all know there are some magnets attached, okay? So, in the motor also children, there's a magnet which is rotating, right? So, in some phone cases, there's a magnetic piece attached to the phone case, okay? So, there are some things that get attracted to magnets, right? So, you all know iron nails get attracted to magnets. So, if you keep some iron powder close to a magnet, the iron powder is also getting attracted to the magnet. So, you will find it very difficult to remove the iron powder from the magnet. Okay? So, you all use needles. Your parents, your mothers use needles for sewing. So, if you keep a needle close to a magnet, the needle will get attracted to the magnet. Okay, so y'all know children, if you keep some paper clips closer to a magnet, all of them will get attracted to the magnet. But there are some things that will not get attracted to a magnet. So here are some examples children. This is a mirror, right? So you all know mirrors won't get attracted to a magnet. So this is a candle. If you keep a candle closer to a magnet, it won't get attracted. So this is a plastic ruler that is also not getting attracted to a magnet. So if you keep a piece of wood close to a magnet, it won't get attracted. So we'll move on children. So y'all know in our day-to-day life, we use different types of magnets. So here are some examples children. This is a bar magnet. It's having a cuboid shape children. So the blue color side is representing the south pole and the red color side is representing the north pole. So this is a U magnet which is having the U shape, right? So in that also the red color side is showing the north pole and the blue color side is showing the south pole. So the other one is the horseshoe magnet children. You all can see two colors separately, but children, the two ends of the horseshoe magnet is representing north pole and south pole, right? So this is a ring magnet children. In that also, now this is having a black color, but in some ring magnets in which they have colored the two colors, the one side is showing north pole and the other side is showing south pole, right? So this is a tabular magnet children. This one is not having a hole at the right middle, right? This one is having a hole in the middle. It's a ring magnet, but this is not having a hole in the middle, so it's a tabular magnet. So children, now y'all know this is a bar magnet, okay? So in a bar magnet, there are two ends. So this blue color side is showing the south pole and red color side is showing the north pole, right? So if you keep some paper clips closer to the magnet, closer to a bar magnet, all of them will get attracted only to the two ends, right? So in the two ends children, the magnetic power is very high, right? So those two ends where the magnetic power is very high can be known as magnetic poles. So children, now we are going to see the behavior of a magnet, right? Here we are going to hang a magnet children. Then we are going to bring another magnet closer to this one, right? So we'll see what is happening when you bring the south pole closer to this south pole and the north pole closer to this magnet, right? Okay. So if you bring the north pole closer to the south pole of the magnet which is hanging, so north pole and north pole is attracting, so an attraction can be seen, right? So if you bring the north pole closer to the north pole, that means similar poles, they are always repelling. So you all can see a repulsion, right? So the same thing is happening. If you bring the south pole closer to the south pole, a repulsion can be seen. So this is another practical, children. You all can take a basin or a bowl, children, then you all can fill it with water. Then you all can keep a rigid form, a piece of rigid form on it. That is also floating. So then after that you all have to keep a magnet on the piece of rigid form, children. Then you all have to bring another magnet above this one, right? So when you move this magnet above or closer to this magnet which is floating, the magnet which is floating will move, right? Okay, so that is happening, children. When you bring the south pole closer to the north pole of the magnet which is floating, the two poles are getting attracted, right? So the magnet which is floating will try to come after the magnet which is kept above that, right? But if you bring the south pole and keep it closer to the south pole of the magnet which is floating, these two are always repelling, right? So then the magnet which is floating will always try to go away from the magnet which is kept above that, right? Okay. So children, this is a very much important instrument. It's known as the compass, right? So sailors, pilots, soldiers, they use this compass to find the direction, right? So there's an arrow, children. It's always showing the north direction, right? So this instrument is used by sailors, pilots, as well as soldiers, children, mainly to find their direction. So children, now earlier in the early practical, we were talking about different interactions between magnets, right? Okay, so children, now this is one bar magnet, that is the other bar magnet, right? If you keep the two south poles of the two magnets closer to each other, you all know similar poles will always repel, right? So you all can see they are always repelling. But if you keep the south pole closer to the north pole, children, the unlike poles, they will always attract, right? So an attraction can be seen, right? So you will find it very much difficult to take the two magnets away from each other. So if you bring two north poles, that means north pole and north pole closer to each other, they are not getting attracted, they are always repelling, right? So they will always try to move away from each other, right? So here in the last diagram, a north pole is kept closer to a south pole, right? So unlike poles are there, so it's always getting attracted, right? So they always try to come together, right? So you will find it very much difficult to take them away from each other, right? So the thing that you all should keep in your mind that similar poles will always repel, but unlike poles will always attract. So finally we are going to talk about magnetic fields, children. Magnetic field means the area where the magnetic power is spread, right? Oh, okay, so this is a bar magnet, children. So onto the bar magnet, we have spreaded some iron powder, right? So this is how the iron powder is getting spreaded, children. So the area where you can see this design is the area where the magnetic power is spreaded, right? So this area can be known as magnetic field, right? So that is a U magnet, children. Okay, so we have kept or we have spilled some iron powder onto the U magnet, right? So that is how the iron powder is getting spread, right? So that is the magnetic field, children, right? So if you take a ring magnet, this is how the iron powder is getting arranged, right? So this is the area where the magnetic field is there, right? So if you take a tabular magnet, children, the iron powder will get spreaded and get arranged in that manner, right? So that means, children, these are the ways where magnetic fields get spreaded, children, right? So these are the areas where magnetic power is spreader, right? Okay. So we'll move on, children. So that's the end of our lesson. So hope to meet you next week with another lesson.